Hey guys, every few years or so, the ACT takes a previously administered ACT test and makes it available to the public to use and practice. And it gets this name, Preparing for the ACT. So if you go search any year, like 2021, Preparing for the ACT, you're going to find a free ACT test, and they don't change it very often. Like I said, they kind of recycle the same test a few years in a row. And soon, in January or so, the ACT, that's January 2025, they're going to be putting out a new one to reflect the changes that they're making starting in April 2025 and then permanently in September of 2025. But the ACT's stance on these tests between, the old test, if you will, and the new test, is that even if the format and the length is changing, the substance is not. So the best way to prepare for the ACT still is in preparing for it like we always have done. So what I want to do today is go through some of the math test of this preparing for the ACT, because this test is good, this free test that they give you that I'm scrolling through here, all this introductory stuff and whatever. This free test it's good in a lot of ways. The problem is they don't give you anything besides the answers. So there's no explanation beyond something like number 17, the answer is B. There's no paragraph explanation. There's certainly no video explanation. So I want to kind of fill in that gap. So today what I'm going to do is I'm going to go through this preparing for the ACT test, the math portion, numbers 1 through 20. And then in the future, I'll do different pieces of this test and put it all together into one, big tool that you can use to prepare. So this is going to take me a little longer than, 15 or 20 minutes going through these 20 problems since I'm explaining everything. But hopefully, if you're out there and you're watching this, you're going to find this useful as you are, preparing for the ACT test. Number 1, the numbers 1 through 15 were each written on individual pieces of paper, one number per piece. Then the 15 pieces of paper were put in a jar. One piece of paper will be drawn from the jar at random. What is the probability of drawing a piece of paper with a number less than 9 written on it? So probably one difficulty in this question, or maybe not difficulty, but one way that students will slip up is they'll think, oh, this is asking what is the probability of drawing a piece of paper with a number 9 or less. But it doesn't say 9 or less. It's asking us for the probability of drawing a piece of paper with a number less than 9. So that would be 1, 2, 3, 4, 5, 6, 7, and 8, right? So there's 8 pieces of paper that have those numbers on them, and there's 15 total. So that makes our probability 8 over 15. There's no way to simplify that, and that's why the answer to number 1 is just E. Number 2, which of the following expressions is equivalent to negative 4x cubed minus 12x cubed plus 9x squared? If this problem was a little more complicated, it would be a good opportunity to use a strategy called picking numbers. You can find that in my ACT math book or my ACT book, the ACT system, step 2. However, in this particular case, all we have to do is add like terms, and that's going to get us to the answer. So we have 2 like terms in this expression that we can add together, the negative 4x cubed and the negative 12x cubed. So negative 4x cubed minus 12x cubed equals negative 16x cubed. And then we have this plus 9x squared on the end. We can't simplify this really any further. Well, we could factor out an x. We could factor out, actually an x squared, we could factor that out. But the answer choices don't go that far. They don't factor it completely. So just adding that one like term gets us to negative 16x cubed plus 9x squared. And sure enough, I see that. Which one is it? J. J is negative 16x cubed plus 9x squared. That's why number 2 is J. Number 3, it says when x equals 2, 10 plus 3 times 12 divided by 3x equals what? So this looks like a PEMDAS question to me, parentheses, exponent, multiplication, division, addition, subtraction. In other words, order of operations. So what we need to do, of course, is take this x equals 2, plug it in right there where there's an x, and then simplify this question, using the parentheses from the inside out until we get a number. So if I rewrite this question with the x equals 2 in there, it would say 10 plus 3 times 12 divided by 3 times 2, just like that. Well, let's start right here, and then we'll work our way out. So I'm going to keep this the same. 10 plus 3 times 12 divided by 3 times 2 is 6. So that's where we are so far. So we're going to keep it in the parentheses, do the 12 divided by 6. Next, to save room down here, I'm going to kind of go up here and draw this. So this would be 10 plus 3 times 12 divided by 6 is 2. And now it becomes much simpler. So 3 times 2 is 6. 10 plus 6 is 16. That's why the answer number 3 is B, 16. Number 4, the absolute value of 6 minus 4 minus the absolute value of 3 minus 8 equals what? So absolute value isn't a concept that shows up on every single ACT math test, but certainly it shows up on most. Absolute value simply means the distance a number is away from 0. So for example, the absolute value of something like -3 would be, well, what's the distance -3 is away from 0? And of course, that's just 3. So what we need to do for this particular question is simplify what's between the absolute value brackets, find the absolute value of those numbers, and then subtract the second one from the first one. So here we go. Let's see, 6 minus 4, of course, in that first absolute value bracket is 2, so this would be the absolute value of 2, minus 3 minus 8 is -5, so the absolute value of -5 between those brackets, and that equals what? Well, the absolute value of 2 is 2, that's how far it is away from 0, minus the absolute value of -5 is 5, because that's how far it is from 0, so that's 5, and that equals -3, and that's why number 4 is G. Number 5, the expression 4c minus 3d times 4c plus d is equivalent to what? So this is similar in a way to number 2 because we're going to have to add like terms. But what this question is asking us to do is to FOIL, which means, well, we have to multiply every number by every other number and then add like terms in the end. So FOIL is an acronym that stands for first, outside, inside, last. And it's a way to multiply two binomials together. This is a binomial because it has two terms. This is a binomial because it has two terms. So I'm going to maybe zoom in a little bit and FOIL these two. So let's see, FOIL means, so first, so 4c times 3c, 4 times 3 is 12, and then c times c is c squared, so 12c squared. Outside, -3d times positive d is -3d squared, so minus 3d squared. Maybe zoom out a little. And then inside, so -3d times 3c is -9, because 3 times 3 is 9, or -3 times 3 is -9. And then we have d times c, so that's just dc. And then lastly, we have the last ones. Well, I might have messed it up, but that's why I underline them, because when you underline each of these terms, when they're underlined twice, you know they've been used 2 times and they're done for. So our last term is 4c times d, and that, of course, is plus 4dc. Okay, or cd, either way is the same. But when we do that, we only have 2 terms that are similar that we can add together. We have like terms. That's right here and right here. These, the 12c squared minus 3d squared, there's nothing we can do with those. We're going to have to leave those the same. If I look at my answer choices, I notice I have the d squared terms on the end, the c squared term at first. So when I simplify this over here, I'm going to make it have that same format. So 12c squared, and then I'm going to put the -3d squared at the end. But -9dc plus 4dc, simplifying that is the same thing as -5dc, or the way this is written here is cd, so it doesn't matter. -5cd, and then minus the 3d squared. Looking at my answer choice options, the one that matches that perfectly well is C, and that's how I know number 5 is C. Number 6, of the 180 students in a college course, a fourth of the students earned an A for the course, 1/3 earned a B for the course, and the rest earned a C for the course. How many students earned a C for the course? So to solve this problem, we simply start with 180, which is the total number of students in the college course. We subtract off those who made an A, we subtract off those who made a B, and in the end, we're going to be left with the total number, which is how many made a C for the course. So to subtract off the number who, made an A, let's just start with that. So 1/4 of 180 made an A. So you can go to your calculator, you can say 180 divided by 4, you can say 180 times 0.25. Either way, you're going to see that 45 students earned an A. So now let's subtract off those who made a B. So minus 1/3 of 180, you might be able to do that in your head and see that it's 60, or you can do 180 divided by 3 in your calculator, whatever the case may be. So 180 minus 45 minus 60 is going to be the number of students who made a C, because that's going to be all the ones left over once we get rid of the A students and the B students. Put that in your calculator, you see the answer is 75 students. And that's how we know number 6 is F75. Number 7. The number of fish F in Skipper's Pond at the beginning of each year can be modeled by the equation f of x equals 3 times 2 to the x power, where x represents the number of years after the beginning of the year 2000. For example, x equals 0 represents the beginning of the year 2000, x equals 1 represents the beginning of the year 2001, and so forth. According to the model, how many fish were in Skipper's Pond at the beginning of the year 2006? So we're given this function f of x equals 3 times 2 to the x power. And I'm going to leave that kind of x power part blank for now, because all we have to do is figure out what x is supposed to be, plug it in, and that'll give us a number or an output, because f of x represents the number of fish in the pond at the beginning of each year. And this question is an example of what's called a modeling problem. A modeling problem is a number that, or it's a question that, quote unquote, like mirrors real life. Number 6 that we just did is an example of that too. And I think the difficulty in this problem, if you're getting it wrong, is just that it's long. Okay, so we're told that x represents the number of years since the year 2000, where 2000 equals 0. Well, if 2000 equals 0, 2001 equals 1, well, 2006 is going to mean that x equals 6. Okay, so our function is f of x equals 3 times 2 to the x power. So f of x equals 3 times 2 to the x power, which is 6. Okay, so we want to put all this in our calculator, of course. If you do 2 raised, well, let's write it like this. So f of x is going to equal 3 times 2 to the 6th power is 64. If you put that in your calculator, you would just type in 2, that little up arrow, whether you're using a scientific calculator or a graphing calculator, you'll find that. And then the number 6 and hit equals, and that's the same thing as 2 raised to the 6th power. There's other ways to do it too, but that's the way I'm doing it real fast. That gives us 64. Put that in your calculator, 3 times 64. You're going to get 192. And that's how we know the answer is B. There are 192 fish in that pond. Number 8. Manish drove from Chicago to Baton Rouge. So first of all, I don't know why he would want to go to Baton Rouge as an Auburn fan, unless maybe it's like Auburn's playing at LSU. That might be a good reason. But nevertheless, Manish drove from Chicago to Baton Rouge. At 8 a.m., he was 510 kilometers from Baton Rouge. At 1 p.m., he was 105 kilometers from Baton Rouge. Which of the following values is closest to Manish's average speed in kilometers per hour from 8 a.m. to 1 p.m.? Okay, so speed here, they tell us, is going to be in kilometers per hour. Okay, so I'm going to write it like this: kilometers over hour, kilometers per hour. So to figure out this answer, we have to figure out the total number of kilometers, put it in the numerator, figure out the total number of hours, put it in the denominator, and that's going to give us his speed in kilometers per hour. Okay, that's going to be our rate. So the total number of kilometers that he drives between whatever it is, 8 a.m. and 1 p.m. is 510, because that's how far he is away, minus 105, because that's how far he is away. And then in the denominator, we have the total number of hours. We just have to count those. So it's from 8 a.m. to 1 p.m., so to 9 a.m., and I'm counting on my fingers. 9 a.m., 10 a.m., 11 a.m., noon, and 1 p.m. is 5 hours, so that's divided by 5. So you can put that in your calculator if you want, and I can write kilometers here and hours here if I want, but I'm going to put that in my calculator. 510 minus 105 equals 405, so that's how many kilometers he drives, divided by 5, which is the number of hours, and that equals 81 kilometers per hour, and that is answer choice H. Number 9. In the figure shown below, E and G lie on AC, D and F lie on AB, DE and FG are parallel to BC, and the given lengths are in feet. What is the length of AC in feet? So what we're looking for is this entire side of the triangle. And the reason it's important that these two segments, DE and FG, are parallel is because it creates a series of what are called similar triangles. So I cover this in my book, The ACD Math System. It's in ACD Math Step 5. In other words, I call this math that's good to know because this doesn't show up kind of like absolute value. It doesn't show up on every single ACD math test. But knowing what a similar triangle is certainly very helpful, especially with problems like this one. Similar triangles are triangles that have the same angle values. So for example, all the triangles kind of within this one triangle, they all share, this angle right here. This is all the same, all these right here. Because these two lines in the middle we already identified are parallel. All of these angles are the same, okay? And for all of them, this angle up here at the top is the same, because we're making all these triangles. So what it means is that their sides are equivalent. So like as 8 is to 16, in other words, it's half the size, so too 7 is to this part over here, huh? So if 8 is half of 16, 7 is half of, I'm going to really have to zoom in and write this in there, 14, huh? And then as 6 is to this over here, huh? So 6 is going to be half, of course, of 12. And now we know all three of those segments, we can add them up to figure out what the length of AC is. So 16 plus 14 is 30. 30 plus 12 is 42. That's how we know number 9 is D, 42. Number 10, Katarina runs 15 miles in 2.5 hours. What is the average number of minutes it takes her to run 1 mile? This is the kind of question that, in my experience, students get to. It seems like it should be simple. They kind of stare at it for a minute while that loading symbol from like memes kind of runs on their forehead, and then they just make a guess and move on. But we don't want to make guesses on this problem. We want to get this problem right, and there's probably a couple of different ways to solve it. But the first way that jumps out at me is to figure out the number of hours it takes her to run 1 mile, because we already have this rate or this ratio in miles per hour. So figure out the number of hours it takes her to run 1 mile. It's going to be a decimal, and convert that to minutes. That seems to me like the fastest way to solve this problem. So we're told that she runs 15 miles in 2.5 hours. And there's two different ways to write that rate. So we could say it takes her 15, or she runs 15 miles for every 2.5 hours. I just converted the 1/2 to 0.5. That's the same thing as saying it takes her 2.5 hours to run 15 miles. Okay, do you see how those two are the same thing? They're obviously not the same thing. It's different rates. This is miles per hour, and this one is hours per mile. But there are different ways of writing this same rate up here. Given that, we have to pick one of these to use to convert this 1 mile into minutes. Okay, in other words, we're going to take this 1 mile number and we're going to multiply it by either this one or this one. But what we need is for miles to cancel out. So we have to pick one that when we multiply the rate, whichever the two, by 1 mile, the miles cancel and we're left only with hours, because our final answer has to be in time, right? We said that we're going to take it from hours and convert it to minutes. So notice that if I pick this one over here, if I multiply this by 1 mile, then I end up in the numerator with miles squared. That's not what we want. So we're not going to pick this one. Okay, we're going to pick this one over here, and we're going to multiply that by 1 mile. So 2.5 hours over 15 miles. I'm going to multiply that by 1 mile, and notice that miles cancels, okay? And that leaves us with 2.5 hours over 15, okay? This is an actual number. So I'm going to take that number and put it in my calculator and just kind of simplify it down to, well, an actual number. So 2.5 divided by 15, that's the same thing as 0.16667, I don't know how far to go, hours. Okay. So the question says, what is the average number of minutes it takes her to run 1 mile? Okay, well, to convert hours into minutes, we have to multiply that by 60, don't we? Okay, so in other words, 0.16667 hours, to convert that into minutes, we could think about it like this, times 60 minutes per hour, and that's going to make hours cancel, you see, and we're going to be left with minutes. So that's going to equal, put that in my calculator, I already have that 0.1667 in there, so times 60 equals exactly 10. Exactly 10. And that's one way to solve this, and that's how I know number 10 is G. Number 11. A bag contains 8 red marbles, 9 yellow marbles, and 7 green marbles. How many additional red marbles must be added to the 24 marbles already in the bag so that the probability of randomly drawing a red marble is 3/5? Well, let's go ahead and figure out the probability of drawing a red marble as it stands now. So that would be the number of red marbles, which is 8, divided by the total number of marbles, which is 7 plus 8 plus 9, because we're told there's 7 green, 8 red, and 9 yellow. And that equals 8 over, let's see, 7 plus 8 is 15, plus 9 is 8 over 24, which is the same thing as 1/3 as it stands. So just like many other ACT math problems, there might be more than one way to solve this problem. But I'm going to do it by using something called back solving. Back solving takes advantage of the fact that of these 5 answer choice options, one of them has to be the correct answer. Does that make sense? So I can plug these in kind of one at a time and see if they work or not. So I'm going to start with C because it's in the middle, because if I start with 20 and it turns out that I need more marbles, then I can just go up to D or E. If I start with C and it turns out I need less, I can just go up to B or A. And that just leaves me one more question to try, because if, let's say, C is not right and B is not right, I know it's going to be A. Okay, so I'm gonna try 20. So let's imagine we put 20 more red marbles into the bag. Well, what would that mean? So that would mean we go from 8 red marbles in the bag to 28 red marbles in the bag, divided by there were 24 marbles, and now we have to add the 20 more. So now there's 44. So if I put that in my calculator, 28 divided by 44, I'm looking for, if I put this in my calculator, I'm looking for an answer that is 0.6, because that's 3/5, right? So I put that in my calculator, I get 0.6363, and on and on and on. So if you think about it, we went from 1/3 at the beginning right here, which is 0.33, and we skyrocketed all the way up to a probability of 0.63. We kind of passed the mark that we're looking for, which is 0.6. That tells me that 20 is too many marbles. We need to go down. So let's try B16. If this one doesn't work, then I know that the answer is going to be A11. So let's try 16. So starting with our original number of marbles, there's 8 in there. I had 16 red ones. Now we have a total of 24 red marbles divided by the word 24. Let's put in the 16 new marbles. That brings the total there to 40. So again, I can simplify this and see if it's 3/5. That would be fine. But I'm going to put in my calculator, see if I get 0.6. So 24 divided by 40 equals, sure enough, what do you know? That equals 0.6. And that is how I know the answer is B, 16 marbles, or 16 red marbles. Number 12, in the standard XY coordinate plane, the point 2,1 is the midpoint of CD. Point C has coordinates 6, 8. What are the coordinates of point D? Okay, so there's a formula out there called the midpoint formula. You probably had to learn it at some point in some math class. Please don't memorize the midpoint formula to get questions like this correct. I don't have the midpoint formula memorized, but I'm not even going to try, okay, because I can just do this instead. I notice that these 2 points are in the first quadrant. They're all positive. So I'm going to draw a graph. I'm going to graph these 2 points out, and then I'm just going to figure out where point D is. So first, let's start with point C. It has coordinates 6, 8. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8. So I know that point C is right here. The midpoint is 2, 1, so 1, 2, 1 would be right here. Okay, so I know that already that point D is going to be somewhere like way down here. Maybe I didn't draw the best graph, but it's going to be okay. But I'm going to think about it like this. So starting at point C, in order to get to the midpoint, I'll just call it M, I have to go down 1, 2, 3, 4, 5, 6, 7. So I have to go down 7 to get there. So starting at this midpoint, I'm going to go down 7. So 1, 2, 3, 4, 5, 6, 7. Yeah, I didn't do the best job of drawing a big graph, but that's okay. But then also from C on the x-axis, I have to go over, 1, 2, 3, 4. So starting over here, I'm going to go over 4. Okay, so knowing this is 2 out. So 1, 2, 3, 4 over here. And sure enough, here's point D. Okay, so again, from the midpoint, you might have been able to think, okay, go down 7 over 4 and just kind of do the math on it from what the midpoint is, which is 0.21. But now I've actually kind of graphed what D is. So D is -1, -2 on the x-axis. So I know it's going to be one of these 2 answer choice options, not any of these 3. And then down 1, 2, 3, 4, 5, 6. And that's how I know the answer is G, -2, -6. Number 13. At his job, the first 40 hours of each week that Thomas works is regular time, and any additional time that he works is overtime. Thomas gets paid $15 per hour during regular time. During overtime, Thomas gets paid 1.5 times as much as he gets paid during regular time. Okay. Thomas works 46 hours in 1 week and gets $117 in deductions taken out of his pay for this week. After the deductions are taken out, how much of Thomas's pay for the work or for the week remains? Okay, so he works 46 hours. Let's start with this. So for the 40 hours that he works on regular time, he gets paid $15 per hour. So 40 times 15 equals $600. Okay, we got that so far. Then he has these extra 6 hours of overtime pay at 1.5 times what he regularly gets. So that extra 6 hours times the $15, but times 1.5. Because remember, he's getting 1.5 times as much as usual. Put that in my calculator. So 6 times 15 times 1.5 equals an extra $135 that he's getting paid. So let's add that up. 600 plus 135, that's a total of $735. But remember, he has this $117 taken out in deductions. So minus 117, that gives us a total of $618 that he gets to take home, and that is D, 618. Okay, number 14. At Sweet Stuff Fresh Produce, the price of a bag of grapes depends on the total number of bags purchased at one time, as shown in the table below. In 2 trips to the Sweet Stuff this week, Janelle purchased 3 bags of grapes on Monday and 4 bags of grapes on Wednesday. So kind of looking down at this chart down here, I already see that this is her, which day of the week? She purchased 3 bags on Monday, and then this one is going to be her 4 bags that she purchased on a Wednesday. Okay. How much money would Janelle have saved if she had instead purchased 7 bags of grapes? So this is kind of our question if she fell in this category of 7 to 9 in one trip on Monday. Okay, so let's figure out how much she spends just the way she did it, which would be Monday and Wednesday. So on Monday, she buys 3 bags. Okay, that's what we're told, and the price per bag is $3. So on Monday, 3 bags times the $3, she spends $9 on Monday. On Wednesday, we're told that she buys 4 bags of grapes then, so 4 total bags, but on that day, or if you buy 4 bags, they're $2.80 a bag. So 4 times 2.8, or $2.80, put that in my calculator real quick, that equals $11.20. So $9 plus $11.20 means that in total she actually spent $20.20. Now the question says, if she had bought all 7 bags on Monday, how much would she have saved? Because she gets a discount for buying 7. So let's figure out what she would have paid if she would have bought 7 bags on Monday. So 7 times that particular rate, which is $2.60. So 7 times $2.60. That equals 2.6 times 7. That equals $18.20. So without even putting my calculator, I see that she spent $20.20. She would have spent $18.20. That's a difference of $2. That's how I know that number 14 is J, $2. Number 15, what is 3% of 4.14 times 10 to the 4th? Okay, well, first, let's figure out what this number is, okay? So times 10 to the 4th, that means basically this. So 4.14. So if it's times 10 to the 4th, that means I need to move this decimal point 4 places to the right, okay? 1, 2, 3, 4. And now my decimal is right there. In these empty spaces are zeros. So 4.14 times 10 to the 4th is the same thing as 41,400. Okay, now the question says, what is 3% of that? And there might be different ways to find 3% of any number, but my favorite way to do that is to multiply the number by 0.03. That's going to give us 3% of that number, and now it becomes a calculator thing. So 41,400 times 0.03, and that equals 1,242. That's how I know the answer to number 15 is A, 1,242. Okay, number 16, what value of x satisfies the equation negative 3 times 4x minus 5 equals 2 times 1 minus 5x? And there's 2 different ways to solve this problem. One of them, of course, is just to solve for x, and that's what I'm about to do. But another one would be to, well, if you don't, let's say it's more complicated, maybe it's not this simple or whatever. Well, another way to do it would be to back solve and to plug these answer choices in one at a time and see which one satisfies the equation. If it's satisfied, that would mean that like on the left, you would get a value of 14, but then also on the right, you get a value of 14, that kind of a thing, okay? But for us, I just want to simplify this down and figure out what x equals. So let's start with this left-hand side. Negative 3 times 4x is negative 12x. Negative 3 times negative 5 is plus 15 equals, over on this side, 2 times 1 is 2. 2 times negative 5x is minus 10x. Okay, I'm going to add 12x to both sides. So I get an even number for x on the right. I'm going to subtract 2 from both sides. So that leaves me with 13 equals 2x. Okay, well, I can kind of from here see what the right answer is. But to isolate the x, divide, whoops, did the eraser there. To isolate the x, divide everything by 2. And sure enough, x equals 13 over 2. That's how number 16 is k. Number 17, in a right triangle ABC shown below, the given lengths are in millimeters. What is the sine of A? So sine, cosine, and tangent. If you have my book, The ACT System, and the ACT Math System, I have a lesson on this in what's called ACT Math Have to Know. These are things you have to know for every single ACT math test. Sine, cosine, tangent, those basics, those trig functions. The sine in a right triangle, of course, of any angle, we'll just call it theta for now, is the opposite side over the hypotenuse, okay? So we're looking for the sine of A, that's this angle up here. The opposite side is, well, directly opposite, which is 7. So let's go ahead and say the sine of A equals the opposite, which is 7, over the hypotenuse, which is, of course, the longest side in a right triangle, over here, which is 9, be 7/9. That's how I know 17 is D/9. Again, number 18. It says 27 divided by 64 raised to the negative 2/3 power equals what? Okay, not to keep harping this book of mine, but in the ACT Math System, in step 2, I have a bunch of little mini strategies like back solving, like picking numbers. And one lesson I include in there is what I call the calculator. And when I call it the calculator, what I mean by that is simply this. Look, in math class, if your teacher gave you this question, he or she would not give you the answer choices and would expect you to simplify this down just given that, using lots of different math properties and math rules and that kind of a thing. And that's all fine and good, but we have this thing on the ACT test called a calculator that I want to take advantage of. Now, I'm going to put this in my calculator, and it's going to give me a decimal. That's totally fine. So here's what I'm going to do. First, I'm going to type in 27 divided by 64. Okay, so 27 divided by 64. That gives me some big decimal. It's like 0.42187.5. Okay, that's a big, long thing. So that number is still raised to the negative 2/3. Well, I'm going to take that number in my calculator and raise it to the negative 2/3, okay? And to do that, we can do that maybe in a couple of different ways. But the way that I'm going to do it is like this. I'm going to type in my calculator. I've already got this decimal here, so when I hit the next button, it's just going to, assume that I'm using this answer. But so I'm going to put this decimal in. I'm going to hit this up button. We used that before, raising a number to a value. Then I'm going to type this in, parentheses, negative 2 divided by 3, okay? Raised to the negative 2 divided by 3 power, and that's going to give me a new decimal number. And guess what? That decimal number is going to match up with one of these 5 answer choices, okay? So I've got this decimal in my calculator, hit the up arrow. So I'm going to raise that to, open parentheses, negative 2 divided by 3, close parentheses, equals, it gives me a value of 1.78 if I'm rounding, okay? And again, there are other ways to solve this problem. Okay, you can get rid of this negative and this exponent by making it positive and moving this whole thing down the denominator. There's other ways to solve this, but this is the way that I'm doing it here. So my question now is, which one of these answer choices, F, G, H, J, or K, matches 1.78? Well, it's definitely not F or G. Those are both negative. Let's try, it's not going to be H either. That's going to be a value less than 1. Let's try J. 16 divided by 9 equals, what do you know? 1.78. That's how I know number 18 is J. 2 more. Number 19. Loto begins at his back door and walks 8 yards east, 6 yards north, 12 yards east, and 5 yards north to the barn door. About how many yards less would he walk if he could walk directly from the back door to the barn door? Okay, so this is kind of like a graphing problem, or the distance between 2 points. So this is a good opportunity for me to actually show you a great way to find the distance between 2 points without memorizing the distance formula, which unfortunately a lot of students think they need to memorize for the ACT test. So if he's going east and north, that puts us in the first quadrant. Okay, so I'm going to draw a graph out like this, okay? So he goes 8 yards east. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so he's right there. Then 6 yards north. 1, 2, 3, 4, 5, 6. So now he's here. And then he goes 12 yards east again. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now he's way over here at x equals 20. And then he goes, 5 yards north. 1, 2, 3, 4, 5. So now he's way up there. So his final destination, or point, if you will, is point 20 on the x-axis and 5 plus 6, or 11, on the y-axis. That's where he ends up. Okay, the question is saying, if he could just do this, just go straight there, how far would that be? Or how much distance would he save walking? So how far does he walk first? Well, it's 8 yards east plus 6 yards north plus 12 yards east plus 5 yards north. And that equals, 14 plus 12 is 26 plus 5 is 31. So he walks 31 yards in that kind of zigzag way. So we got to find the distance between the origin, which is 0, 0, and our new point 2011. See how far that is, subtract it off from 31, and that's going to be how much space he saves. Okay, well, looking at my answer choices, I'm just going to go ahead and guess that by walking from the origin to point 2011, he's not going to save 31, 26, 23, or even 19 yards. That would be incredible. That would be an incredible amount of yards that he's going to save if he were to walk a straight line instead of zigzagging a couple of times, okay, in a 31-yard walk. I already know, without even doing the math, that the answer on this based on answer choices is going to be A, okay? So if you can spot that and you can be confident in those answers, then hey, go for it and choose A. However, I promise you from the get-go that I would solve this in a different kind of way. So again, a student might look at this and say, I don't remember the distance formula. I don't know how to use the distance formula, so I can't find the distance between these 2 points, so I can't find the distance, so I give up, so they're just going to guess. Don't do that. The distance formula between 2 points is based on the Pythagorean theorem. The Pythagorean theorem, if you remember, is for right triangles. It's a squared plus b squared equals c squared, where a and b are two of the legs of a right triangle, and c is the hypotenuse. That is not a good triangle, but you get the idea. This is something that you absolutely must know for every ACT test, okay? So instead of memorizing the distance formula to find that distance, let's use the Pythagorean theorem instead, because look, if I draw a line right here straight down, it forms a perfect right triangle, doesn't it? And I know that this length right here is 20, and I know that this length right here is 11, and now I can use the Pythagorean theorem to find that distance, instead of just memorizing a distance formula. So using the Pythagorean theorem, let's call this C, I guess. So this would be 20 squared plus 11 squared equals c squared. 20 squared is 400 plus 11 squared is 121 equals c squared. So 521 equals c squared. Now to solve for c, we have to take the square root of everything, because the square root of c squared is just going to be c. So I'm going to write this kind of up here now. So scooting over. So what's the square root of 521? So 521, whoops, I did squared on accident in my calculator. So second square root, 521 equals 22.83 equals C. So fortunately, my first thought is that's not a whole number. All our answers are in whole numbers. If I subtract 22.83 off of 31, it's going to give me not a whole number. But the question says about how many yards. So it's approximate. So if it's a distance of 22.83, that's how far he would have walked if we would have just walked in a straight line. So 31 minus 22.83, if I put that in my calculator, 31 minus 22.83, I get a distance of about 8.17, which is about 8, which is another way to solve this problem and figure out that 19 is A. Either way you do it, number 19 is A. All right, lastly for this set, number 20. For a given set of data, the standard score Z corresponding to the y-score X is given by Z equals X minus mu over theta, where mu is the mean of the set and theta is the standard deviation. This is bringing back lots of bad memories of my college statistics courses. If for a set of scores, mu equals 78 and theta equals 6, which of the following is the raw score X corresponding to Z equals 2? Okay, the ACT typically includes one question just like this in every single ACT math test. I have it in my book in the lesson called Higher Algebra in ACT Math that you have to know. What they're expecting most students to do on this question is to get kind of scared and think, well, I don't know what any of this stuff means. I don't even know how to pronounce this, so I don't know how to get this right. They're going to give you, like I said, about once every ACT math test, an algebraic expression that looks something like that, or it's got a bunch of variables that you don't know. But trust me, they're going to give you every single variable except for one, and then you're going to have to solve for the one missing variable, okay? So our expression is z equals x minus mu over theta. And guess what? They give us everything here except for x. So we're told here that z equals 2. So that's going to be 2 equals x minus, we're told that mu equals 78. So minus 78 over, we're told that theta equals 6. So over 6. And now we can solve this. If we were told at the beginning of this problem, 2 equals x minus 78 over 6, what's x? Then 90% of students are going to be able to solve it. But by wrapping it up in this longer question with difficult looking variables, much less students are going to be able to solve this question. But I don't want that to be you. So let's go ahead and solve for x. Then the first thing we got to do is get rid of this 6 in the denominator. Multiply both sides by 6. We're going to get that 12 equals, these cancel, x minus 78. Add 78 to both sides. We're going to get that 12 plus 78 is 90. So 90 equals x. And that's how I know that number 20 is F. Okay, if you're interested in that math book I mentioned over and over again, the ACT Math System or the ACT System, which has the math part in it, I'll link to those in the description below. But next time, we'll get back to numbers 21 through 40. Thanks, guys.